Welcome to Writing XS in Plain C. I have to give credits for this talk to Stefan Mueller, who came up with the concept of this style of teaching of XS code. The code samples that are in this talk are on GitHub in a special branch I pushed today. Again, I have to give thanks to Stefan Mueller because he invented this style of lecturing, of explaining how XS works. My name is Bulk88. I have a PAWS ID, and I'm mostly seen in the Perl community on the P5P mailing list. And I mostly use Perl on Windows, and I do a lot of Perl, Windows, and C coding, and general Perl and C coding. The Perl interpreter is written in C89. It is a large pile of machine code, and it is memory unsafe. The Perl interpreter is not written in Java. There are basically two ways to escape the Perl language sandbox. You can use XSUBs, or you can manipulate the op tree and use keywords. XSUBs can be monkey patched. Keywords are permanent. There's no monkey patching of keywords in the Perl language. Also, Perl is kind of fat, so sometimes you have to use C for speed and performance reasons. XS code is generally converted to C code by a program called XSUB PP, and it was introduced in Perl 5 Alpha 4 back in 1993. XSUB PP is a descendant of a tool called mus, which was introduced in Perl 3 in 1990. Mus was originally created to allow curses to work in Perl 3, I guess. I was barely alive then, so. To understand why XS is so hard to program or use, you have to understand that XS was written in the era of K and R C, not C89, but K and R, because C89 was 1 year old when XS was, the predecessor to XS was invented. Also, XS is generally considered to be macro soup. The pros of using XS is you have actual source code compatibility, and you're not using undocumented calls for everything. Also, the macros can be upgraded internally without breaking your code. And pretty much everything I tell you today is undocumented APIs, so don't cry to P5P if your code breaks because you use a pile of undocumented APIs. And also, all the code samples only run on 522 because, again, there is no compatibility if you skip the official public API. How to make XSUBs appear in the Perl language. The main tool used is XS Loader or Dynaloader, and your PM file calls XS Loader calls DLload file. The yellow stuff is C code, and the blue boxes are pure Perl subcalls. You have to first load a shared library into the Perl process. XS Loader then will take your package name, prefix boot, and replace the colons with underscores. That then calls dlfind symbol, and dlfind symbol goes and asks the OS shared library loader, please give me the C function pointer for this particular symbol name. And this is the only function that needs to actually be extern or publicly available in your shared library. Then XS Loader takes the C function pointer that the OS returned, and it calls dl install XSUB. This actually connects the C function pointer into the Perl language and makes it connectable and creates a type glob with a subroutine inside that you can now call from the Perl engine. Once this bootstrap sub is created in the Perl language, it gets dispatched. This is the first time you get control in Perl in the C language. Normally, the boot XSUBs generally call new XS and register all additional XSUBs in the process that your module will be using, because there's one central XSUB that registers everything else traditionally. After you've registered all your additional XSUBs, XS Loader pretty much exits and immediately returns control to your PM file. Every single Perl XSUB follows the following C prototype. All XSUB function pointers must have this prototype. I will be using one or two macros in this talk. I said I'm not going to show you macro soup, but the first argument is a Perl engine pointer, and on no thread builds the argument has to be removed, and on threaded builds you have to have a Perl engine pointer. The PTHX macros allow the engine pointers to be dropped out of your code based on whether you're using threaded or unthreaded Perl builds. But the other parameter is a CV pointer, which is basically a pointer to a subroutine in the Perl C side of things. The CV has, this is pretty much the layout of the CV. The green things are the most interesting things to an XS programmer. The red stuff is only used for pure Perl code, and sometimes as an XS programmer, the yellow stuff will be useful. Up here, we have the C function pointer that you're going to be calling. You write the C function that goes up in here. And there's also one void pointer that the Perl engine doesn't use for anything called any. And you can cache, you can do things like building closure subs, and stick like a C++ object pointer in here for quick lookup. But this has no backing or ownership, so generally anything you stick in any, the pointer has to be owned by a magic struct that lives in the linked list of magic. It's faster to look up the XS any member than to go searching the linked list for magic every time you want to get your private closure information for the sub, for the XSUB. The Perl stack has a couple design requirements for it to work in the Perl language. Perl has no strict prototyping, so every subroutine is, and few people ever use want array to strictly enforce context. There is list and void and scalar, but they're optional if you want to care about them. And the Perl language doesn't force context on you. Also, the Perl stack has to implement call frames because this is Perl and not BASIC, and we're not using goto lines to switch function calls. At underscore is actually a window into a chunk of the Perl stack, and each call frame gets its own at underscore with a window into pieces of the Perl stack. There is a local that's going on behind the scenes that swaps out what at underscore is pointing to. And the Perl stack can be reallocated at any time, so you can grow it to 128 petabytes on Linux, 128 terabytes if you want on Linux. I don't know if anyone wants a Perl stack that big. Generally on the Perl stack, your incoming arguments also become your outgoing arguments to your caller. And you can only store the null pointer and reference counted things like scalars and hashes, array pointers on Perl stack. You cannot store random pieces of data on the Perl stack. It has to be a valid reference counted pointer at all times. Context is really an artificial concept in the Perl stack. It's really just how many arguments you passed in and how many arguments something returned. If you do want the want array information that you would have in the Perl language, it is available in C, so don't worry. The Perl stack generally starts at something called PL stack base. And when writing an XSUB, you heavily interact with the mark stack and the Perl stack. In order to know where your section of Perl stack begins, you have to look on the mark stack. The mark stack consists of indexes into the Perl stack. These are indexes, these are not pointers. So you have to read what is underneath PL mark stack pointer, get that I32, and then take PL stack base, and using pointer arithmetic, you just add the two, and you know where the start of your section is of Perl stack. But the start of your section is generally something called the mark pointer. And what is underneath the mark pointer is not your memory address, which is red. Your elements, if you get any incoming elements, they're going to be after the mark pointer, which would be the yellow zone, the first two yellow zone, the yellow zone. PL stack SP is the end of your section of, temporarily the end of your section of the Perl stack. It is always underneath the last valid element that you are receiving in your XSUB. If PL stack SP is equal to the mark pointer, you got 0 incoming arguments. And do not try to dereference what is the SV pointer that is underneath PL stack SP if PL stack SP is equal to your mark pointer. In theory, on the Perl stack, you could have a private zone in the middle where you could store additional SVs. Almost no XSUBs do this because they traditionally store SV pointers on the C stack, not on the Perl stack. And if you want, you can call additional subroutines by allocating yet another chunk of Perl stack further down the line. And that becomes the outgoing arguments to your callees. You have to also remember to bounds check whenever you are extending or putting things on mark stack and on the Perl stack, because this is C and everything has to be bounds checked at all times. The minimum XSUB, this is the rule of every XSUB has to do this. It has to decrease the mark stack pointer by one element. This is the minimum XSUB that you can write in plain C. And generally it returns @_ in pure Perl, the equivalent of what this code does. Let's count the number of @_ arguments your XSUB gets. Every XSUB generally has a prologue which consists of reading the Perl stack pointer, getting the index off of the mark stack, and then computing the mark pointer based on a combination of the start of the Perl stack and our index. Items is generally the stack pointer minus mark. So if SP is equal to mark, you got 0 elements and you have no incoming arguments at all. And here is our obligation to decrease the mark stack pointer by 1. We create a new Perl scalar. Generally, the Perl stack does not own any SV pointers that are on it. All SV pointers on Perl stack have to be owned by something else. If you don't know what's supposed to own an SV, put it on, mortalize it, which is an alternate stack of just temporary ownership of things. We set the SV to our items count. Now we have, because this is a var_arg subroutine, we have to wipe all of our incoming arguments, and we do that by assigning mark to SP, which backs SP up all the way to the start, and effectively we have now 0 arguments on our section of the Perl stack. Because we could have been called with an empty list, we have to still bounds check our stack pointer and reallocate it if necessary to put one element on, because we could have gotten 0 incoming elements in our list. Because SP at this point is on the mark, is underneath mark, and mark is an invalid memory address for us, we advance SP by 1 and we put our SP by 1, we put our SV pointer on the Perl stack, and then we save the location of Perl stack to the global copy of SP for our caller to figure out what we're returning. How to print a scalar. We have the same prologue that you saw earlier, and generally this is a lot of repetitive code to write XSUBs manually. That's why nobody does that. We have to check the number of items because we could have gotten 0 to infinity items in any subroutine. So we always have to bounds check how many items we got if we're going to read anything off Perl stack. Now to extract a string out of a scalar, we can check the flags, and if the flags are okay, we can directly read the char pointer that is inside the scalar. Else, we have to call a casting function which will convert our scalar into a char pointer that we can use. We then print the scalar, and here, because we know we only have 1 item, we can just decrease stack pointer unconditionally by 1 and assign it, and we know that we'll be returning an empty list because we have the earlier check that we only have 1 element. How to sum, this algorithm sums the entire list and adds the numbers. Here we back up SP by the number of incoming items, but SP is now the same thing as mark in this subroutine, so when we dereference SP, we have to do +1 because the element under mark is not valid for us. Again, as with the string pointer, we have to check the flags. If the flags are okay, we can directly dereference. We can directly read the double value that is in the scalar, else we have to do the casting stuff. Again, because we could have gotten an empty list, we have to bounds check the Perl stack before we can create a new scalar and put it on the Perl stack. Now for some really crazy stuff. This is a pure Perl version of the following code I will explain on how for an XSUB to directly call an XSUB without the help of the Perl engine. Here we have a typical prologue that every single XSUB contains, and in order to call a child XSUB, we have to put our own mark stack, we have to create our own mark entry for the child to pop off. We have to bounds check the mark stack just the same way that we bounds check the Perl stack. We also have to, in this sub, what we're going to do is we're going to copy our incoming Perl stack arguments to a section of outgoing Perl arguments. So we're going to basically have 2 blocks on Perl stack with the same contents, because after calling each subroutine, the arguments you sent out are wiped because the outgoing section is also used for the arguments you get back. from each subroutine. To call an XSUB directly in C, each XSUB requires its CV pointer. So we fetch the CV pointer from the Perl engine, and we can directly call the XSUB. We have to put the stack pointer back after we create our new outgoing zone so that the child sub can find all of our arguments. We directly call the C function, which is an XSUB, without going through the Perl engine. And then we refetch the stack pointer to see how far it was adjusted and whatever returning arguments we have. Down here, we have to calculate how many items our child gave us. We're basically recomputing the mark pointer based on stack pointer, and if it's wrong, we fatally error. Else we can read back the one element that our child was supposed to return. We can call a sub again. In this case, because we earlier bounds checked our mark stack, we don't need to repeat extending the mark stack. We can just directly advance it by one and assign our outgoing mark. Again, because every subroutine can reallocate the Perl stack and the mark stack, we have to recompute our mark pointer from the basic information of the index. We then can perform the memory copy and recopy our incoming zone to the outgoing zone. We can then call another XSUB directly from an XSUB. Again, this is all undocumented. But you have to understand how the Turing machine works in Perl. We call a subroutine again. We have to fetch the stack pointer and check it again for the arg count. Now that we have our count and our sum, we can compute a string and again call another subroutine directly and print the values that we got from our earlier child calls. And at the final thing, we need to return an empty list. So again, we have to recompute the mark pointer, and by assigning mark directly to the global stack pointer, we're saying we're returning 0 arguments to our caller. Questions? You have to bounds check everything, but you only need to bounds check things once. Again, most of the stuff I told you today is undocumented, and it'll probably be broken in 524, and this code won't even compile on 520. But compared to 3-letter macros, and you don't really know what they do, and you just copy-paste them, I think this is a lot more intelligible on what the XS code you write actually does on a Turing machine level and how it interacts with the Perl engine, rather than a bunch of copy-pasted macros that you don't know what they do. I'm not here to teach you that. You can just read Perl. I'm not going to read Perl API to you because that's just pod. You can read that yourself. I mean, this is a very innovative way to try to explain what these macros do without using them. Any other questions?
Should I correct the mistakes?
Go ahead.
First, reuse the stack so you don't create outgoing arguments. You just reuse the incoming arguments.
Yeah, but I'm copying them repeatedly. I'm passing the same adding to 3 different subroutines.
You have different paths. For each recursive function call, you've got a separate path list. You've got your
XSUBs don't have pads. Only pure Perl code has pads. The CV struct, the pad list is not used for XSUBs. I actually recycled it in 522 for this member, which I added. So XSUBs do not have pad lists.
It makes no sense to keep the old stack.
We're keeping it rather than copying it to a pile of C autos or mallocing a new block or using alloc A. This is to explain how the Perl stack works, and you can keep private arguments on the Perl stack.
Okay, so if you wanted closures, or using something like pad, that's a good idea. Keep it.
The pad equivalent would be using the XS any member down here, along with magic.
You never mess with mark pointer unless.
Yeah, you can't. The mark pointer is given to you. It's a read-only value. You can never go behind it.
And you only need mark if you use enter leave, because otherwise you don't need it.
All XSUBs are they're not opcodes. They're not keywords. They are subroutines. They have to use mark.
You can write something fast in
This is about XSUBs. This is not about keywords. That's the other alternative I mentioned. Direct opcodes don't necessarily use marks. They don't have to use the Perl stack. They can do crazy stuff. XSUBs have to follow a certain ABI, and they have to look like pure Perl subroutines, and they have to sort of follow the same API and ABI requirements. Question? Okay, I guess we're out of time. Huh?
The next step, I guess, would be how do you write one of those functions and then link it into the Perl interpreter?
I didn't have time to show a boot function. The boot XSUB. That there was the yellow diagram at the beginning. I ran out of time. Thank you. Thank you.